So, good evening, everyone. My name is Chaitra Borkar, a Ph.D. research student from Department of Chemical Engineering, IIT Delhi, and I welcome you all to the NPTEL course of Basic Environmental Engineering and Pollution Abatement. This is the first live session that is to be conducted. So, a few points to be noted before we start off. These live sessions will occur on every Saturday from 3 to 5 p.m. and the live sessions link have already been shared with you all. And these sessions will be recorded, and the recording will be made available to you through my YouTube channel. And the structure of these sessions will be that there will be first the overview of the lectures that were given to you for the corresponding week, and then we'll solve a few sample problems. So we'll start with the overview of lecture 1. So it started off with the introduction of the subject and why the subject of environmental science and engineering is necessary to study. So because of the increasing population growth, increasing energy demand, and the industrial development, there has arisen a need to study our environment and the impact that our activities have on the environment. And if there are any issues occurring with the environment, so how we can solve them. So then the environment was the term environment was defined, and along with its components. So its components are either biotic or living components, or abiotic or non-living components. So this interrelationship of these biotic and abiotic components then constitutes ecosystem. So and this ecosystem has a number of natural restorative cycles, in the sense that if there are any disturbances created in the environment, uh, there are some cycles which can help in restoring the environment to its original state. But if because of some reason and due to the excessive disturbances created in the environment or the ecosystem, there can be a possibility of generating of lot of waste because of the failure of these restorative cycles. So because of that, the type of waste that can be generated that can be solid waste, liquid waste, or aqueous waste, or gaseous waste. And these wastes can be hazardous or non-hazardous in nature based on their toxicity, reactivity, ignitability, and corrosiveness. So, as we all know, that because of the excessive human activities, there has been a few environmental crises that have occurred in the past years. So, what we can do about it? We can either conserve the resources which are provided to us by the nature, or we can modify certain conventional techniques that we use for our basic subsistence, so that less pollution is generated, or we can treat the waste that is generated so that less amount of pollution is emitted into the atmosphere or the environment. Lastly, the terms environmental science, engineering, and environmental studies were discussed. So, the environmental science is the study of the environment and the issues that take place into the environment. And environmental engineering is how to deal with those issues. So, the techniques and methods that can be developed so that the environmental issues can be dealt with is environmental engineering. And environmental studies is basically the impact of human activities on the environment, and also a holistic study of the environment. So now we move over to lecture 2. So lecture 2 comprised of discussing ecology, environment, and biodiversity. So ecology is the study of this interrelationship between the biotic and the abiotic components. Uh, and environment is the natural world that we live in, and biodiversity uh, is constitutes a number of species of plants and animals uh, in the ecosystem. There are various levels of organization, such as we there is a species of some organism, and that a number of those species constitutes a population. Different populations of species then forms a community, and community along with its biotic and abiotic components constitutes an ecosystem. And a number of ecosystems having the same climate and geometry and the geology uh, constitutes a biome, and a number of biomes then constitute a biosphere. So the components and the operation of ecosystem were then discussed. So components, as I have already said, that it can be biotic or abiotic components, and these abiotic and biotic components are related through a chain. So it is called as food chain, and it is the process of eating or being eaten. So firstly, what happens is the energy from the sun is converted by the plants, which are the primary producers, into food, which is then consumed by the primary consumers. So plants are primary producers, and the herbivores are primary consumers. And then these primary consumers are then consumed by the secondary consumers, which are carnivores and other carnivores. So it's sort of chain forms which links these different components of the ecosystem. So next, there are a number of elements which exist in our environment in different phases, and they form a cycle of sorts. In that they are circulated from one phase to the other. For example, these are called biogeochemical cycles, and for example, the water cycle, if we know that the large water bodies, they evaporate water in the form of water vapor, and these water vapor then are converted into clouds, and then clouds into rain, and if these rains fall in colder regions, they can form ice or snow, and this ice or snow then melts into glaciers, which forms rivers and lakes and constitutes a fair amount of groundwater as well, and then this flows back into the ocean. So this cycle continues. Same goes for carbon, nitrogen, and phosphorus, which have been discussed. Next, the if an ecosystem is such that if a disturbance is created, uh, but that disturbance is because of the natural restorative cycles, that disturbance is accommodated by the ecosystem. So that can be called a stable ecosystem. But if an ecosystem, because of the external disturbances, it is not able to sustain itself, and even the disappearance of a single type of species causes its failure, then it's called a less diverse ecosystem. So, a stable ecosystem is basically which has a diverse number of species of plants and animals, and a less diverse ecosystem will have a diminished amount of those organisms. So, so highly diverse ecosystems have this tendency of providing us with a few services which are called the ecological services. So these services are basically related to provisioning us with food, water, shelter, and then if we have these basic necessities, then we develop over them and form communities, and which give us cultural values, social values, health values. So these kind of services were then discussed. And if these services are then consumed by us, but the excessive consumption of these services also leads to a disturbance in the ecosystem. So that we need to keep check on. And if that is not kept check on, then it leads to the imbalance in the ecosystem. So, if then how to restore the ecosystem to its original state? So we need to. There are two ways to do that. It can be active, that we directly work on the direct human intervention into the activities that are going on, or the passive restoration, that the nature itself works on restoring the environment or the ecosystem. So in lecture 3, it was discussed about the ecosystem services and its risk. So services can be about provisioning, as I discussed, that it can be food, water, shelter, supporting the life forms that are present on the earth. Then cultural, in the sense that it provides education, you have a community around you, health values, and everything. And regulation is that if there is some pollution being generated, then how to reduce that pollution so that it does not create a nuisance. The contamination of resources has been a major issue, and because of these contamination, there are a number of phenomena that occur. So the bioconcentration is one such phenomena in which, if there is a harmful substance, and that is being consumed by the organism. So in the surrounding there's a harmful substance, and if by some way it is being consumed by the organism, so there will be a chance of higher concentration of that substance in the organism than in the surroundings. So to measure that this bioconcentration phenomena, a bioconcentration factor was discussed about, and how to calculate that through empirical relations was also discussed. Next, the bioaccumulation. So bioaccumulation is the phenomena in which the harmful substance is not being able to be rejected by the organism which has consumed it. So, and it depends on the rate of uptake, that how fast you have consumed it, mode of uptake, like how you have consumed it, and the duration it takes to eliminate that substance from the body. If the duration is very slow, so then it will take a lot of time to be eliminated from your body. And biomagnification. So biomagnification is the phenomena in which the concentration of the harmful substance increases when we move further up the food pyramid, or the food pyramid, which is the basic, which can be considered interchangeably with the food chain. So if we go from bottom to top, so bottom has producers and top has consumers. So if we go up the food pyramid, so that concentration of the harmful substances increases by many folds. And that factor can be 3 or 4 or something like that. Then the effect of transmission of diseases has, as we have seen in the past, there have been many examples. One of the example is COVID-19. It also has a major impact on the environment. The lecture 4 was the continuation of the ecosystem services. So the terms such as risk and hazard were introduced here. So risk is basically the probability of an adverse event occurring, and hazard is the potential to cause harm. So we can say that risk is the function of hazard and the exposure of that hazard. And to save ourselves from this hazardous situation, there needs to be some risk analysis that is to be done. So it has 4 components, which is hazard identification, that you need to identify what are the harmful substances that can be detrimental to you. And after that, you need to assess the risks, that in the sense that if there is some hazardous component around you, do you, I mean, is it in that concentration that will cause you harm, or is it in the permissible limits? And if it is not in the permissible limits, then you need to take a decision about it, that how to eliminate it, or how to save yourselves. or the community. And that decision, when you take that's called risk management. And when you take that decision, you need to also communicate it to the all the stakeholders which are there in your community, so that they also know that this is the risk which is involved, and that is called risk communication. Another term, exposure, which was discussed. So, exposure to a harmful substance is basically the product of intensity, that how much was the harmful substance you were exposed to, and frequency, that how many times you were exposed to, and the duration, that how long you were exposed to it. Next, the intake rate was talked about. So, intake rate is the function of a lot of factors. It also constitutes the intensity and the frequency and duration, and also the concentration of the substance. And next, the dose response assessment for carcinogenic and non-carcinogenic materials was discussed. And terms such as slope factor for carcinogenic substances, which is the slope of the plot for dose and response. And the non-carcinogenic substances, there are terms such as reference dose, NOAEL, which is no observable adverse effect level. So that this term is such that after this dosage level, there can be some adverse effects that can be observed. And threshold is the maximum limit. So after that, there will be a high response curve. Then the terms such as hazard quotient in terms of reference dose and NOAEL were discussed. And if there are a lot of pollutants present in the environment, then the summation of this hazard quotient for each harmful substance is the hazard index, as well as the lethal dose. Lethal dose is basically the dosage at which a percentage of population diminishes. So LD50 basically means that the amount of dosage of a harmful substance which can diminish about 50% of the population. So this was about the overview of lectures. Next, we will discuss about the assignment 0. So assignment 0 is the first question was that contaminated water can be purified by removing. If we see here that contaminated water, we don't want any of these components in our water that we consume. So undesirable chemicals is not we want. Biological contaminants we do not want, and heavy metals so we don't want. So all of the above is the correct answer here. This was fairly easy. Next, we go to what is the health effect of excess fluoride in drinking water. Can anyone tell me what the correct answer is? Just one of you who can answer.
Fluorosis.
Fluorosis.
All right, thank you. You can mute yourself. So, yes, correct answer is fluorosis. This is the phenomena of excess fluoride in your body system. And why this fluoride is added to the drinking? Could you please mute yourself? There's a lot of disturbance. Yeah, thank you. Fluoride is basically added to the drinking water so that it maintains the dental health. But if excess of fluoride, so excess of fluoride can be above 1.5 ppm itself. So we need a very less amount of fluoride in our drinking waters. So if a lot of fluoride is there in your drinking water, it can cause a lot of problems in your body. So this is called fluorosis. Next question is, find out the most suitable option from the following representing the dissolved oxygen content in natural water at normal pH. So one information that can be given here is that oxygen is a weakly soluble gas in water. So and its concentration increases when we decrease the temperature. So there are 4 options given here, and we can say that if it's weakly soluble, but it can't be less than 1 ppm, or it can be 1.1 to 2 ppm. Why? Because it needs to sustain at normal, at least temperature, it needs to sustain life forms. So it can't be so less. And it can be more than 12 ppm at normal temperatures. Why? Because it's weakly soluble. So the most plausible answer here is 8 to 9 ppm. And can anyone tell me if there is any relation related to equilibrium, which gives the concentration of gas dissolved in a liquid or a mixture, which is related to the concentration of the gas in the atmosphere above it. Can you tell me any equilibrium relation that you have studied before? Anyone, if you know?
Yes.
Can you tell me? Hello? Okay, so you may know, but you did not answer. So I'll tell you, it's called Henry's law. So Henry's law is basically the partial pressure of the gas into Henry's constant into the mole fraction. So mole fraction of that gas in liquid or the mixture, and partial pressure of that gas in the atmosphere above it. So Henry's law basically gives the concentration of gas either in the um, gaseous phase or in the mixture phase, if you know the other two terms. So next question was, which of the following does not contribute to the pollution in aquatic bodies? So here you can see that heavy metals, as we know, are a big pollutants in aquatic bodies, microplastic as well, and pesticides, because of the um, fertilizer runoff. They can get introduced into the water bodies. So here I can say that ozone. Ozone is the one which basically is not a pollutant in aquatic bodies, and we can also think it that way, is that ozone is basically an oxidizing agent. So it will oxidize the impurities which are present. So this is the correct answer here. Can anyone tell me the answer for this one? Which of the following fuels causes minimum environmental pollution? Is anyone present?
Yes, this is
Hydrogen,
hydrogen.
it is the cleanest fuel.
Okay, so you said it is the cleanest fuel, but do you know any pollutants that are emitted while hydrogen is combusted? Can you tell me? Or there is no pollutant which is emitted while hydrogen is combusted?
Only water vapors are emitted when
हाँ, तो
hydrogen is combusted.
do you know hydrogen combustion is whether it is exothermic or endothermic? Hmm?
Not sure about
Okay,
this.
that's okay. So hydrogen combustion is highly exothermic, and the temperatures can go very high. So, and if the hydrogen combustion is occurring in the presence of air, so air also has nitrogen in it. And at very high temperatures, nitrogen also gets combusted and it forms NOx. So, yes, hydrogen combustion can emit a fair amount of NOx. So, it's not the only water vapors that are emitted. NOx can also be emitted when hydrogen is combusted. There is a possibility for that. So yes, the correct answer, as you said, it's hydrogen. Next question is, which of the following is a waterborne disease? So here we see that typhoid, we know that it's a waterborne disease. Same goes for cholera, and diarrhea is basically the symptom of these two. So we can say that diarrhea or dysentery is also caused by waterborne diseases. So here the answer is all of the above. Next question is, which of the following is not a greenhouse gas found naturally in the atmosphere? So can anybody tell me the answer for this?
Carbon
Ozone.
dioxide.
Huh?
Ozone.
No, this is methane.
Ozone.
All right. Why do you think ozone naturally found in the atmosphere?
Carbon dioxide it is.
Carbon dioxide is found naturally. How do plants then make food?
It's a,
They intake carbon dioxide,
okay,
correct?
okay. Yeah, right.
I had given you the answer before while discussing the hydrogen one.
NOx.
Yeah,
That is
correct.
nitrogen oxide.
Yeah. So NOx is not found naturally in the atmosphere. Methane can be found naturally because of the decomposed bodies. They do emit methane. And ozone, we have this ozone layer in the atmosphere so that the UV radiations are not, the effect of the harmful UV radiations does not reach us. And carbon dioxide, as I said, that plants consume it to make food through photosynthesis. So NOx is basically, we have nitrogen in our atmosphere, N2. So when it is combusted, it forms NOx. So NOx is not naturally found in our atmosphere. And yes, all of them are greenhouse gases. So, next question, which of the following particles is called the particulate pollutants? So, is, could you please let me know the answer for this one as well? It's fairly easy.
Fly ash.
Yes, correct. Because all of the others are in gaseous phase. Ozone is a gaseous one, radon is a noble gas, ethylene exists in gaseous phase at normal temperatures and pressures. So yes, fly ash is the answer here. Next question is, which of the following salts are the main causes of temporary hardness? So, for temporary hardness, the salts which cause them are the salts of carbonates and bicarbonates. And here we see that first three options do not have the carbonates or bicarbonate salt. They are sulfate and chloride, which actually form permanent hardness. So the answer here is magnesium carbonate. The last question for assignment 0. So here you need to find the most suitable option from the following representing the pH of the rainwater. So we know that rainwater is a bit slightly acidic. So it will not be 8 to 9, and it will not be 2 to 4 as well. Why? Because 2 to 4 is fairly acidic range, and 5 to 6 is the slightly acidic range. So yeah, the most plausible answer here is 5 to 6. So this was about assignment 0. Now we'll discuss about assignment 1. So this is the first question, and these are the sample questions. These are not the actual assignment that was given to you. So this is the first question, and based on these solutions, you can solve your assignment 1 as well. So which of the following option appropriately connects the oil type with API gravity range as provided in the table below? So API gravity range, I'd like to discuss it first. So that the API gravity range is inversely related to the specific gravity of a substance, and specific gravity is basically the density relative to the reference density, which can be of water. So as more the dense a substance or more heavy a substance, it API will be low in number. So here, if we look at the options, so first we'll go with light oil. Light oil is the lightest among all four here. So light, heavy oil, bitumen, and medium heavy oil. So light oil is the lightest one. So it will have the highest API gravity range here. So if you can see, it is the option 2. So we'll connect P with 2. Next, we discuss about medium heavy oil, which is heavier than light oil but lighter than heavy oil. So it will have the next API gravity range, which is 27 to 22. Next, the heavy oil. Heavy oil will have the next gravity range, which is 22 to 10. And bitumen will have the last option left, which is greater than 10. So the correct answer here will be P2, Q1, R4, and S3. Next question is environmental engineering is the application of scientific and engineering principles to improve and maintain the environment. Yes, correct. We want that. Protect human health. Yes. Protect nature's beneficial ecosystems. Yes, as we discussed. So yes, all of the above are correct. The next question, can anybody answer this for me? This is the diagram of food chain. So you need to answer what is A and what is B. Can anybody answer?
Uh, D. A is herbivores and B is other carnivores.
Yes, correct. So as you can see from the image itself, the energy from the sun is converted by the plants into food, which are primary producers. Then it is taken up by primary consumers, which will be herbivores. Then secondary consumers, carnivores, as well as the other carnivores. So yes, the correct option is A are herbivores and B are other carnivores. Yes. Thank you. Next question is generally photosynthesis reaction is given as. So photosynthesis, we know that the carbon dioxide, water, and energy are taken up by plants and made into food. So what is that food? That food is glucose. So here, if we look at the formula of glucose, is wrong in all the three options other apart from the first one. So the correct answer here is first option. So, and you need to also look at the balancing of the equation, that all the molecules that are there in the reaction equation are balanced on both sides, reactant as well as the product side. So yes, this is the balanced equation for photosynthesis. Next question is primary treatment of municipal wastewater can remove around this much percent of solids and this much percent of BOD. So according to the discussion taken up by the course instructor in lecture 1. In lecture 1, they discussed about wastewater treatment, and in that they taught about the levels of treatment that are taken up to purify the water. So first it is the pre-treatment, which removes the grit and the solid mass. Next is the primary settlement, which removes a certain percentage of solids as well as BOT. Next is the secondary treatment, and finally is the advanced treatment. So here, according to the definition given, the answer will be 60% of solids and 35% of BOD. So the answer here is the third option. So question 6 is, what is the full form of NOAEL? Can anybody give me the answer for this?
A.
No observable adverse. Yes, correct. Yeah, that is the correct answer for this. And this is related to the dose response effect of non-carcinogenic materials. So yes, this the first option is the correct. Okay, so bioaccumulation of any substance depends on, as I've already discussed this before, it all depends on the rate of uptake, mode of uptake, and how quickly the substance is eliminated. So yes, all three options are correct here. So all of the above. The study of the interrelationships between plants and animals that live in a particular physical environment is called. So we know ecosystem is constitutes the interrelationship between plants and animals, but the study of it is called ecology. So the correct answer here is ecology. The next question is identify the biotic component of the ecosystem from the options given below. Biotic components are the living components of the ecosystem. So here the third option, which is living plants, is correct because air, water, soil are the abiotic components. And last question. Sorry. So last question. Consider a solution of ammonium sulfate prepared by dissolving 54 gram of the anhydrous compound in water and diluting to 1 liter. What is the concentration of the solution in moles per liter? So you may have seen the answer, but the correct answer here is 0.4 moles per liter. But how will you get to that answer? I'll just let you know the solution for that. So as you know, ammonium sulfate is NH4 whole twice SO4, and the molecular weight for NH4 to SO4 is 132 grams per mole. So this is the molecular weight. And now we have been given the amount of the ammonium sulfate which is present in the solution. So for moles per liter concentration, basically we are calculating the molarity. So first we'll find out how many moles are there. So number of moles is N, which will be 54 grams upon the molecular weight. So 132 grams per mole. So which comes out to be 0.409 moles. And we now need to calculate the molarity or the concentration in terms of moles per liter. So here I define it as M, which will be moles of salt upon volume of the solution. So moles are 0.409 and volume is 1 liter. So it basically comes around as 0.4 moles per liter. So the correct answer here is the last option, 0.4. So anybody has any doubts regarding this session or any concepts that you may have come across? Any doubts?
Hello. Yes, ma'am. In assignment one, in one question, in which KOW is given, there are four options, but when I solve the question, I'm getting an answer which is none of the four options. Can you
So
please check the question number 4 it is?
yeah, I do know I did solve it, and the option is one of the options. The correct answer is one of the options given in your assignment. So I'll ask you to recheck your calculation first, and I'll just give you a hint for it that the KOW and the BCF have some empirical relation, correct?
Yes, yes.
हाँ, so you need to see that दोनों तरफ log है. So you need to take the anti-log. Did you take the anti-log?
दोनों तरफ log नहीं है ना
Log
the
BCF is equal to 0.79 log KOW
okay
minus 0.4.
it's log BCF.
Yes.
Okay, I was looking
You
at
need to
BCF
make
is equals
sure.
to
You need to make
okay.
sure that you take the anti-log when you need to get the BCF value. And this
Okay.
goes for everyone. Whatever the relation is there, you need to check thoroughly that you have taken either the log or anti-log properly. All right. Any other doubt?
No.
Anyone else who has any other doubts?
Uh, if we submit one assignment and
Mm-hmm.
we later on, like I have submitted my assignment and now I got it ki question number 4 can be corrected. So can I resubmit it?
As far as I know, the knowledge that I have, you can resubmit it and the final submission of yours will be considered. That is what I know. But you need to just confirm it once, or I'll confirm it and let you know. All right.
Okay, thank you.
Please, can I know your name?
It's Anuja Kalra.
Anuja. All right. Thank you.
Thank you.
Just a minute. I think somebody posted a question. So I'll just stop sharing my screen. Somebody raised a hand. Sherry, you can go ahead and ask your question. What is your question? Is there any question you have, Sherry? Okay, if nobody has any question, then I'll go ahead and close this live session for today. Thank you everyone for joining.